So we're going to do some simplifying of exponential expressions. And when an exponential expression is simplified, our coefficients are simplified. Each base only appears one time, and there are no negative exponents. So we're going to be using our laws of exponents to help us simplify these powers here. But our first thing that we have to do is simplify our coefficients. So when you simplify your coefficients, you simply do whatever mathematical thing your problem says. So like in this case, 4 times 3 gives me 12. So when I simplify those coefficients, they become a 12. Now to simplify my exponents, remember it says each base can only appear one time, we're going to follow our laws of exponents. When we have a to the second times a to the fifth, and we're multiplying the same base with different powers, remember our rule is that we add those exponents together. And the reason we do that, remember we have a to the second, which looks like this, and we have a to the fifth, 1, 2, 3, 4, 5, which means when we add them all together, we end up with a to the seventh. So that's how we would simplify that. Now the same thing goes if you have a division problem, except you're going to follow your division rules. So the first thing we're going to do is we're going to divide our coefficients here. We're going to do 12 divided by 6. 12 divided by 6 gives me 2. Okay, the other thing you can think about, like if this was a fraction and we simplified this, it would look like that, right? Okay, well the next part is we're going to simplify these coefficients, or these exponents. B to the 8th divided by b to the 3rd. So remember, our rule says, our law for exponents says we subtract those exponents, and we would do 8 minus 3, which would give me b to the 5th. Now let me explain why that works out. B to the 8th, that's like we have this, 4, 5, 6, 7, 8, okay, over b to the 3rd. So we have 1, 2, 3. Remember, when you divide, these are going to cancel out. So these two would cancel out, these two will cancel out, these two will cancel out. And what we're going to be left with is 5 b's that are part of our numerator. So remember, this whole thing is like it's over 1. Now, you can follow your rule, which is just subtracting these powers. But for me, in my head, because sometimes you're going to, when you subtract, you'll end up with a negative exponent. The easiest thing for me to do is just think of it in terms of this. Like the first thing I'll think about is, where do I have more b's? Are they in my numerator or my denominator? And I can see 8 is more in my numerator. And I think, okay, well, how many more? If I have 8 on the top and 3 in the bottom, that means I have 5 more in my numerator, which means this is going to be b to the 5th. All right. Now, those two problems didn't have a negative exponent. This one does. Now, I'm going to show you how we can do this problem following our laws of exponents, and then I'm going to explain kind of a shortcut way to do it that might help you. Okay, so let's start looking at this b to the 4th, or b to the negative 4th. Remember, when you have a negative exponent, what happens is that negative exponent will turn this into a fraction. You get a numerator of 1, and that negative power of 4 becomes your denominator, b to the 4th. Now, this b to the 2nd, that's already part of our denominator, is down here. Oops, sorry, this pen stopped writing. So this b to the 2nd is already down here. Now, if I'm going to follow my laws of exponents, what I'm going to do is the 1 is going to stay up here on the top. B to the 4th and b to the 2nd is going to give me b to the 6th. Okay, because this is like I have 4 b's and 2 more b's, which gives me 6 b's total. So that's what's going on. Here's our shortcut. Anytime you have a negative exponent, what that means is it's automatically going to drop to the denominator. Or if your negative exponent's in the denominator, you're going to move it up to your numerator. So the way I would do this problem is I'm going to take this b to the negative 4th, and I'm going to draw this arrow and drop it down. So in my head, I'm going, okay, I've got this, and now my b to the 4th is going to be on the bottom. But I also already have this b to the power of 2 on the bottom. Now if you look, this is exactly what I have here. Okay, so this is just kind of a shortcut way for me to remember. Whenever you have a negative exponent, it's just going to change positions in your fraction. And this will leave me with my final answer of b to the 6th. So now let's put everything together. So sometimes you're going to have problems where you need to distribute, and then you're still going to follow the kind of the rules that we had for simplifying. So first things first, let's distribute. And whenever you have a power that's outside your parentheses like this exponent, oopsie, applies to everything inside your parentheses. So this power of 2 is going to give me 4 to the power of 2. And then this a, which was to the first power, is also going to be to the second power. So we're going to multiply that power of 2 to everything because we distribute. We're going to do the same thing on the bottom here. This power of 2 is going to apply to the 2, so 2 to the power of 2. And then this a to the 4th down on the bottom is also going to be raised to the power of 2. All right, so we're going to simplify that a little bit. So 4 to the second power is 16. 4 times 4 is 16. A to the first power raised to the second power is just going to be a to the second power because we multiply those two powers together. 2 to the second power, 2 times 2 is 4. And then finally a to the 4th power raised to the second power is going to give me a to the 8th power. So a lot going on here. All right, so we distributed. Next thing we're going to do is simplify our coefficients. So right here this says 16 divided by 4. 16 divided by 4 is 4. That 4 is going to be part of my numerator because if I simplify this like it's a fraction, this is what we get. The 4 is on the top. So I'm going to end up with a 4 as my numerator. Now, let's use our new kind of thinking on this. If I look at this, I have 2 a's on the top. I have 8 a's on the bottom. I have more a's on the bottom. Okay? I have 2 on the top, and I have 8 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. If I were to cancel these out, these two cancel out, these two cancel out, I'm left with 6 a's that are down here on the bottom. So I have more on the bottom, 6 more. So this is what my answer to that problem is. I know it looks weird, but we're just following our rules. Okay, last problem. Nothing to distribute. We're going to simplify our coefficients here. So we have a 14 and we have a 2. 14 divided by 2 is 7. Okay, next we're going to move those negative exponents. So this is my negative exponent. I'm going to take that, I'm going to move it up to the top. So let's rewrite this. On the top I have 7. I have this original x to the power of 3. And now I'm going to move this x to the power of negative 2 up to my numerator. On the bottom here, all I'm left with is I have this number 1. This x to the power of 2, negative 2, has moved up top here. So now last but not least, we just have to simplify this. Simplify your coefficients. 7 over 1 is just 7. And then we have x to the 3rd and x to the 2nd, which means I have x to the 5th because I have 3 x's and 2 x's. That gives me 5 x's altogether.